Okay, we'll definitely wrap up this chapter with this one. I'll make some additional points on tipping points in the Earth system. So now we'll try to pull it together for the system as resilience, robustness, and sustainability. In recent years, the concepts of resilience and robustness have been increasingly used in the debate about sustainability. How do they relate to each other? Sustainability refers to a goal one aims to achieve. Sustainability guides the discourse on the interaction between human societies and the environment, often focused on specific sectors, so sustainability of water, energy, sustaining biodiversity, or so on and so forth. Um, there are many dimensions of sustainability, varying from avoidance of depletion of natural resources, avoidance of inequality, and stimulation of quality of life for everyone, and striving for a just society. So that's where norms come in. Each culture may see justice and equity differently, and protecting the vulnerable, elderly, young women, and so on differently in terms of how much they would spend to do social protection for vulnerable ones. Okay, so resilience and robustness ideas can be used to define system properties that may help decision makers to achieve sustainability. Robustness focuses on feedback systems with clearly defined boundaries. Robustness comes from an engineering and robust control systems background or area. It can be used to address questions about how to control a system to reach a target, such as sustainability. Right? Robustness enables us to think about decision making, Robustness enables us to think about decision making, which information to use, how fast to respond to changes, and to think about trade-offs in decisions to be robust to certain shocks but not to others. Resilience provides a framework to think about how multiple systems, each operating at their characteristic temporal and spatial scales, interact across scales, so local to global, or daily to yearly to decadal, and so on and so forth. I just had lunch and I'm feeling a little tired. Human decision making can affect the resilience of a system by changing the shape of a particular stability domain. We'll see that in a minute with an animation that I just got from European Space Agency, which also relates to the stability well that we looked at before. So this can be intentional with a goal, for example, catalyzing a transformation of a fossil fuel economy towards a solar powered economy or a renewable powered economy. Hence, resilience of a system in a particular stability domain is not always desirable, and human activities can shape the long-term dynamics of the system. So this is where we are saying by increasing global greenhouse gases, we are having some many impacts across the climate components. So temperature warming, humidity increase, extreme rainfall increase, droughts, sea level rise, glacial melting. They're all kind of feedbacks within the system coming from increased greenhouse gases. But we also have land use change, urbanization, which are feeding again onto the same components and creating internal feedbacks. For example, CO2 increase also affects evapotranspiration of the plants and how they use water efficiently in a high CO2 environment, and so on and so forth. So you have a very complicated Earth system, and then figuring out where the tipping points are and how when we may approach them or how close we are to them becomes very, very complicated. So in that context, let's look at this nice figure made by Will Stephan, big proponent of Earth system approach, who died recently. So I think you may have seen it somewhere. Basically, we are looking at the Earth system with external forcing coming from the sun and volcanic eruptions and fossil fuels. So in that sense, you know what external forcing or forcing means. Anything that perturbs the radiation balance at the top of the atmosphere in terms of reducing or increasing the solar radiation that reaches the surface, or reducing or increasing the thermal energy that is trying to go out. So volcanoes take out stuff that's buried away from the climate system and throw it into the atmosphere and perturb the radiation balance. Human beings are taking out fossil fuels that are buried away from the climate system and burning it and producing greenhouse gases which affect the radiative balance and create a forcing as well. So that's the Earth system, and I won't go into the details. You have geosphere, biosphere, anthroposphere, where human beings do a lot of things, and then climate change happens on this side. You can think of it as geological ecological system interacting with the human system, and then we have to worry about inequality and poverty and justice and so on that we have been talking about. So there are feedbacks within each one, right? Within the geosphere you have cryosphere, stratosphere, troposphere, and climate being created, and we are increasing greenhouse gases, and they affect directly the biosphere as well as through the changes in the cryosphere and the troposphere, which is the lower part of the atmosphere. And there is of course the ocean, the upper ocean, lower ocean, coastal zones, freshwater and freshwater ecosystems, vegetation and roots and soils, and of course you have a lithosphere with its erosion and earthquakes and other things. So you have the human system, which is now a problem because our energy systems, our energy intensive lifestyles create greenhouse gas emissions which feed directly into the climate system. And we have knowledge, science and technology, where we are trying to increase energy production, like digging for fossil fuels or solar, or trying to reduce our impact as well. So that works through institutions, politics and economies. So economic growth motives may drive coal use, but then that is bad for greenhouse gases, human health and so on. So you have resource extraction happening, and you have production and consumption of the resources having direct feedback to the biosphere and the the Earth system as a whole. So you also have human population with its cultures, values and beliefs that make us worry about inequality, poverty, adaptation, mitigation, just, equitable and so on and so forth, right? So you can imagine how many feedbacks there are and how many tipping points there are, but people sit down and think about it for us. So I will look at a tipping point figure in a minute. So there is a there is a way to turn this there is a play button here somewhere that I'm looking for, but is this it? No, that goes, yeah, there it is. So we have a stable state, and let's say this is like natural variability, where you have year to year or decade to decade changes that are not related to human activities. Human activities come and change this dynamic by, let's say, making natural variability more sustainable to jump to a new state. So some tipping point gets crossed. So human activity may be affecting oops, now I have to go back and do that again. Oops, now I lost that. So let me go back one more, come back, and now will you let me play it again? Yeah. So small perturbations from human activities may still remain within the bounds of natural variability, but land use, excessive fossil fuel burning, stability rate changes in the atmosphere, Amazon deforestation and so on may change the system so that natural variability can then become wild and go into a new state where, let's say, it's hot, humid, and a lot of droughts and floods and extreme rainfall, fewer glaciers and sea level rise and so on. So here are the kind of tipping points that are envisioned by Europeans. So the European Space Agency. So was this slide. Europeans are obsessed with tipping points, especially Tim Lenton from the UK and a bigger team. They keep on writing these papers, and they identify these tipping points, potential tipping points. Boreal forest northward expansion, Arctic winter ice collapse can happen, boreal permafrost abrupt thaw is possible, Labrador Sea subpolar gyre can collapse, Greenland ice sheet can collapse. Again, these are definitely potential possibilities, but when? when will we get there? So here we are looking at tipping points likely within 2 degrees C warming. Not everybody agrees on this because this is not based on any robust science or a model that is reliably able to produce such turnovers, tipping points, switching states, etc. 2 to 4 degrees. So you can see many are argued to flip, tip over, Sahel greening, West African monsoon strengthening, Amazon dieback, and so on. And you have red spots where you have East Antarctic ice sheet collapse, East Antarctic subglacial basins can go at 2 to 4 degrees, and so on. So the main question is, this is our system. We want to manage the performance of this system, let's say by avoiding these tipping points, but how on earth can you do it? That's fairly impossible for an open system like this. When you talk about a classroom university, you have a closed system with some open boundaries, but basically well controlled, whereas here you have energy coming in and going out, and you have energy being dug up and burned, and again radiation interacting with space. So you have an open system which has so-called emergent solutions as opposed to convergent solutions, where solutions can emerge from interacting components of this system that have no analog states or things we haven't seen before. Okay, so these are the kind of things one worries about. Coming to the end, critical reflections. With systems perspective, we consider the components of the system and their dynamic interactions. The institutional analysis and development framework we discuss in this book is a systems perspective of human behavior, institutions, and the environment in which they are embedded. Systems also have characteristics such as resilience and tipping points that we mentioned, which we can observe in social as well as ecological systems. Tricky thing is to expect them and to predict them, and even to what actions precisely are needed to avoid them or delay them. Make yourself think. The next time you take a shower, reflect on your ability to control the temperature. Right? What do you know an example of a resilient system? What would be an alternative outcome for this resilient system that you know? If it tips over, then what will be the alternate stable state for it, and so on. Okay, so just carry these thoughts forward to the next chapter in the systems perspective. So let me leave this here for now. I will come back and go to the next chapter. Okay.